Okay, today I am going to explain about the solution of non-homogeneous linear differential equation. In the solution, there are mainly three cases. Case 1 is if RHS function phi of x is exponential. Next case is trigonometric functions, that is basic trigonometric functions, sin ax or cos ax. And third one is polynomial x power n. Okay, now come to the first case or type 1. If phi of x is exponential e power ax. Okay, in this case, see, general formula for pi is phi of x divided by f of d. Now write phi of x as e power ax and f of d is the polynomial operator. To find the pi in case of exponential function, replace d differential operator d by a. What is a? Coefficient of x in the exponential function. Then d square becomes a square, d cube becomes a cube, etc. Then pi becomes e power ax divided by f of a. This denominator f of a is not equal to 0. Very important. F of a should be non-zero quantity. Suppose f of a is 0, then pi is x into e power x divided by f dash of a. Multiply numerator with x, differentiate the denominator with respect to d, and again replace d by a, d square by a square, etc. And again same condition, f dash of a is not equal to 0. Denominator is not equal to 0 by chance. Again denominator becomes 0, f dash becomes 0. Then pi is x square. Again multiply numerator with x. Then differentiate the denominator again with respect to d. Then replace d by e. What is the condition? F double dash of a is not equal to 0, etc. Okay. Till we get the non-zero quantity in the denominator, we have to continue this process. And subcases of the type 1 exponential. First one, see, if it is e power ax, we replace d by a. If it is e power minus ax, replace d by minus a. Coefficient of x is minus a. And if the exponential function is multiplied with constant k into e power x, write the constant as it is till the end, then replace d by a. Same procedure. There is no change in the solution, right? K till the end as it is. That's it. Next, if we have only constant term k, then write that k as k into e power 0x. E power 0 is 1. 1 into k, it remains same. Then here coefficient of x is 0. Replace d by 0 and continue the process. Next, if it is k power x, k power x can be written as e power log kx by taking log on both sides. Okay, finally we get e power log kx. Now in place of a, what we have? Log k. Replace d by log k. Next, k power minus x. It can be written as e power minus log kx. Here a is minus log k. Replace d by minus log k. Next, if the given functions are hyperbolic functions, sin hax or cos hax. See, sin and cos, hyperbolic functions are defined in terms of exponential function. If it is sin hax, e power x, write it as e power x minus e power minus x divided by 2. Take 1 by its outside from the bracket. Then we get e power x minus e power minus x. First term replace d by a. Second term replace d by minus a. And simplify. In case of cos hax, e power x plus e power minus ax divided by 2. Take 1 by it outside from the bracket. Write it as e power x plus e power minus ax. Again same procedure, replace d by a in the first term, d by minus a in the second term. Okay, now come to the problems. First problem. Given differential equation is second order, non-homogeneous linear differential equation. Okay. Here, solution consists of two parts for non-homogeneous, CF and PI. You have to find both complementary function and particular integral. How do you find the complementary function? While solving the homogeneous linear differential equation, you know how to find CF using the roots of the auxiliary equation. Okay, here also same thing, right? Auxiliary equation, replace d by m. Okay, m square 5m plus 6 and equating to 0. Find the two roots. Here two roots are real and distinct. Write the CF. Okay, already I explained how to find the CF in different cases. Okay, now come to PI. Here you have exponential e power minus 3x and constant term. There are two terms. Okay, e power minus 3x plus 10 divided by d square plus 5d plus 6. This is your polynomial operator. See, split it into two terms because we have two terms here. E power minus 3x by d square plus 5d plus 6. And 10 can be written as 10 into e power 0x divided by d square plus 5d plus 6. Here replace d by minus 3. Here replace d by 0. Okay, and before going to replace d by the coefficient of x, first observe the roots of the auxiliary equation. Here roots are minus 2 and minus 3. Okay, here what is the coefficient of x in the exponential function? Minus 3. Minus 3, same value is a root. Then we get to 0 in the denominator. Very simple. Coefficient of x in the exponential function is a root of the auxiliary equation. We get to 0. That's it. Suppose same value repeat two times. Say for example minus 3. Then we get 0 two times. Denominator terms become 0 two times. That means f of a 0, f dash of a is also 0. F double dash is not equal to 0, like that. Okay. Since minus 3 is a root, we get 0 one time. If you replace d by minus 3 here, we get to 0. See, minus 3 square, 9. Minus 3 into 5, minus 15. Plus 6. Plus 6, 9 is plus 15, minus 15, 0. Okay. Then multiply numerator with x. Differentiate f of d one time. What is derivative of d square? 2d. And derivative of 5d is 5. Now replace d by minus 3. Minus 3 into 2, minus 6. Plus 5 is minus 1. X e power minus 3x divided by minus 1 is the PI of the first term. Now come to second term. Coefficient of x is 0. Replace d by 0. This term is 0. This term is also 0. Plus 6. 0 plus 6. 6 only. 10 by 3 e power 0x. Sorry, 10 by 6 e power 0x. 10 by 6 can be written as 5 by 3. E power 0 is 1 only. Okay. Now PI is PI of the first term plus second term. Now what is the general solution? CF plus PI. Although we find the CF, add CF and PI gives the general solution. Okay. Similarly, go to the next problem. Second order linear differential equation. Here independent variable is t. In the previous differential equation, independent variable is x. Okay, you should write in terms of x, solution in terms of x. Here independent variable is t, means you should write the general solution in terms of t only. Okay, now write the polynomial operator, auxiliary equation, find the two roots. Here two roots are real and equal. Real and equal. Write the CF. You know how to find the CF. But while writing the CF, you should write same independent variable. Don't write in terms of x. Since t is independent variable, write in terms of t. If x is independent variable, write in terms of x, like that. Okay. Now come to the RHS. E power 5t divided by f of d plus 5 power t can be written as e power log 5t divided by f of d is d square minus 10d plus 25. Okay. Now come to the first term, which is very important. What is the coefficient of t here? 5. 5 is a root. How many times? 2 times. Correct? That means we get 0 in the denominator 2 times. That means f of 5 is 0. F dash of 5 is also 0. Differentiate f of d 2 times. Okay. So f of d is this one. Differentiate one time, we get 2d minus 10. Differentiate again, we get a 2. Now, in f double dash of d, replace d by 5. Here there is no t, there is no d here. Okay, since no d term, f double dash of 5 is 2 only. Okay, 2. Then what is pi? Since f double dash is not equal to 0, after replacing d by 5, you have to multiply numerator with the t square. e power minus 5t, then f double dash of 5. Okay, suppose 5 repeats 2 times. In that case, t cube e power 5t divided by 2, right? Divided by whatever the non-zero quantity in the denominator. Okay. Now come to the second term. Replace d by log 5. That's it. No need to simplify. No need to find the value of log 5. Just replace d by log 5 and leave it. That's it. Now, general solution is CF plus PI. This is your CF. This is your PI. Okay. Next problem. Third problem. In the third problem, given differential equation is third order. F of d is polynomial operator is d cube plus 3d square plus 3d plus 1. Auxiliary equation, find the roots. Here roots are real and equal. Repeats how many times? 3 times. Write the CF. You know how to find the CF. And RHS, we have e power minus x. PI, e power minus x divided by d cube plus 5 3d square plus 3d plus 1. Okay. What is the coefficient of x here? Coefficient of x is minus 1. And minus 1 repeats how many times? 3 times. That means we get 3 times 0. If we replace d by minus 1, f of minus 1 0, f dash of minus 1 is also 0, f double dash is also 0. F triple dash is non-zero quantity because coefficient of x repeats 3 times while in the roots of the auxiliary equation. Therefore, find f dash, f double dash and f triple dash. In f triple dash, there is no d term. If you replace d by minus 1, we get 6 only. F triple dash of minus 1 is 6. Now, you have to multiply numerator with x cubed because minus 1 repeats how many times? 3 times. F triple dash is not equal to 0 means multiply with x cube. Okay, x cube e power minus x divided by 6. Now, write the general solution. CF plus PI. Okay, next one. Solve the given differential equation. Here RHS is hyperbolic function. Okay. Now m square minus 4 is equal to 0. Find the roots. Plus 2 and minus 2 are the roots. Roots are real and distinct. Write the CF. Now come to the RHS. Cos h 2x minus 1. And second term is 3 power x. That is 3 power x contains e power log 3x. Now cos hx can be written as by using exponential function e power 2x minus 1 plus e power minus of 2x minus 1 divided by 2. And RHS, sorry, second term, e power log 3 by 2 divided by d square minus 4. Here, take 1 by 2 outside. Then we get to 2 terms. This is your first term, second term. But in the second term, multiply with negative sign minus 2x, it becomes plus 1. Okay. Here, replace d by 2. In the second term, replace d by minus 2. But 2 is a root. How many times? 1 time. That means f of 2 becomes 0. And here minus 2 is also root. Minus 2 repeats how many times? 1 time. Therefore, f of minus 2 is also 0. Okay. Differentiate f of d 1 time. F of d is d square minus 4. F dash of 2. F dash of d is 2d. Now, in this term, replace d by 2 and d by minus 2 here. F dash of 2. 2 into 2, 4. Okay, for the first term, f dash of minus 2 is minus 4. Okay, then PI is, since f of 2 is 0, f dash of 2 is not equal to 0, multiply with x divided by 4. Here, multiply with x because minus 2 is also root. Repeat 1 time. Okay, and divided by minus 4. This is your PI for the second term for 3 power x. Right. PI by simplifying, multiply this 2 into 4, 8. Here also minus 8 and third term. Write the general solution with the CF and PI. Okay. Now come to the next problem. Given differential equation is third order, non-homogeneous linear differential equation. Write the auxiliary equation, find the roots. Here roots are real and distinct. Okay. Write the CF. Now come to the PI. There are 2 terms. Write 2 terms here in PI. Okay. For the first one, e power minus 2x divided by f of d. Second one, 2 power minus x contained as e power minus log 2 into x. Here replace d by minus 2. Here replace d by minus log 2. Okay. Now come to the first term. Minus 2 is the coefficient of x and minus 2 repeats how many times? one time. That means f of minus 2 is always 0. F dash of minus 2 is not equal to 0. Okay. See, find derivative of f of d, that is f dash of d. Differentiate 3d square plus 12d plus 11. Find f dash of minus 2. That is, if you replace d by minus 2 here, we get minus 1. Then for the first term, multiply numerator with x, and f dash of minus 2 is minus 1. Okay. For the second term, replace d by minus log 2 and leave it as it is. CF plus PI gives the general sum. This is your CF and this is your PI. Okay. Next problem. Third order differential equation. Okay. And here we have 3 terms in the RHS. Auxiliary equation. Find the roots. Write the CF. First term, e power 1x, e power 2x and e power 3x. See here. E power 1x. What is coefficient of x? 1. 1 is a root. How many times? 1 time. That means 1 time we get 0 in the denominator. Come to the second one. 2 is a root. See? 2 is a root. That means f of 2 is also 0. 3 is also root. F of 3 is also 0. That means for all the 3 terms, we have to find f dash of d. Differentiate 1 time. And then replace d by 1 for the first term, d by 2 and d by 3 for the next 2 terms. Okay. Then multiply. Multiply numerator with x like this. X into e power x and x into e power x, and find f dash of 1 here. Okay. And here also x into e power 2x divided by, find f dash of 2, and here same thing, x into e power 3x divided by f dash of 3. Find the whatever the value and substitute here. Okay. That gives PI. Then finally write CF and PI. Okay. Next one. Y triple dash minus y is equal to e power x plus 1 whole square. D cube minus 1. Auxiliary equation m cube minus 1. Find the 3 roots. Find one root by synthetic division method. See here. Or you can use calculator also. By using calculator, you will get 1 and minus 1 by 2 plus or minus root 3 by 2 I. Okay. This is your CF. Now come to the PI. RHS is e power x plus 1 whole square. By using a plus b whole square formula. By using a plus b whole square formula, expand it. A square plus b square plus 2ab. Then we get e power 2x 1 and 2 into e power x. Here coefficient of x is 2. 1 can be written as e power 0 and 2 into x. Coefficient of x is 1 here. Roots are real and imaginary. Okay. One root is real. Next 2 roots are imaginary. 2 is not a root. That means we get non-zero quantity directly. 0 is also not a root. We get non-zero quantity directly. But what is the coefficient of x here? 1. 1 is a root. For the third term, you have to differentiate d cube 1 time and then replace d by 1. Okay. See. For third term, we required f dash. F of d is d cube minus 1. Find f of 2 directly and f of 0 directly. For the third term, differentiate f of d. F dash of d is 3d square. F dash of 1 is 3. Okay. Then PI is e power 2x by 7. E power 0. If you replace d by 0 here, sorry, e power 0 is minus 1. Okay. E power 0 is minus 1. Actually, these 2 terms, they interchange here. This is minus 1. Okay. Next. And second one, 2, multiply with x here. Because 1 is a root 1 time. Okay. We have to differentiate 1 time. Then f dash of 1 is 3. Okay. This is your PI. Write the general solution. CF and PI. Okay. This is about the type 1 exponential function. Okay. Next class I will explain type 2 trigonometric functions, sine and cos. Okay.